Picture this. You're at the checkout. You pull out your phone, you tap to pay, you're waiting for that little ding of success, and instead, nothing. Just silence. And then that dreaded notification flashes on your screen. The whole thing just gone. We've all been there, right? You feel that little jolt of panic. A split second of, wait, what? You know the money is in your account, so what on earth just happened? Where did things go wrong?
You know, it feels like a total glitch in the matrix, some kind of random error. But here's the thing, it's not random at all. There's a reason. There's a trail of digital breadcrumbs left behind. And today, we're going to follow it.
So let's pull back the curtain on this. Every single one of these failed payments, it leaves a trace, a clue. And if you know how to look, you can follow that trail all the way back to the source. This isn't some digital ghost story, it's basically digital forensics. Our investigation is going to center on one of the biggest real-time payment systems on the planet, UPI. It was launched back in 2016 by the National Payments Corporation of India, and it handles billions with a B of transactions. So yeah, when something goes wrong here, it affects millions of people. So every good investigation needs a crime board, right? Well, in the world of digital forensics, they have something called a fishbone diagram. Think of it like a map that lets them lay out every possible suspect, every single path that could lead to the scene of the crime, which in our case is that failed transaction. Once they've got the map of suspects, the next step is good old-fashioned deduction. For that, they use a technique called fault tree analysis. It's kind of like a detective starting at the crime scene and then working backwards, step by step, to find the exact moment things went south. All right, so before we can point any fingers, we have to understand the whole network. Every person, every device, every piece of code, it's all part of the crime scene. So let's map this whole thing out. This right here is our central mystery. It's the head of the fishbone, the very top of our fault tree. A single, super frustrating UPI transaction failure. And from this one event, this massive web of potential causes just starts to spread out. Our first suspect? Well, it's the person holding the phone. We're talking about simple human errors. Mistyping your PIN because you're in a hurry, getting one single character wrong in the payment address, or maybe even hitting a daily spending limit you completely forgot about. Any one of those simple mistakes can stop a transaction cold. Next up, we've got to investigate the getaway car. Your phone. Maybe your app is out of date and it can't talk to the bank system properly. Or your battery's about to die, causing the whole thing to just glitch out. It's the machine in your hand failing you at the absolute worst moment. Then we have to look at the process itself, that invisible handoff of data from one system to another. What if the bank server is just totally slammed? If its response comes back just a fraction of a second too late, the entire system can time out and just kill the whole transaction. And finally, we've got to question the environment itself, the invisible network that connects everything. A weak Wi-Fi signal in the back of a cafe or a totally congested cell network at a concert. If the message can't get through, well, the payment can't be made. Simple as that. So after mapping out all of that complexity, the user, the device, the process, the network, the investigation starts to reveal a pattern. It turns out all those countless possibilities, they really boil down to just two main categories of failure, two prime suspects. And here they are. This is the core of it. Every single failure, no matter how complicated it seems, can be sorted into one of two buckets, a business decline or a technical decline. And trust me, understanding the difference between these two is the key to solving our case. So a business decline is basically any failure that starts with you, the user. It's when you punch in the wrong PIN, or try to send money from an account that doesn't have enough cash in it, or you try to go over your bank's daily limit. In these cases, the system is actually working perfectly. It's just correctly rejecting a request based on the rules. A technical decline, on the other hand, is completely out of your control. This is when the system itself is the one that messes up. Maybe the bank server is down for maintenance, or there's a huge system outage, or some communication error between the banks. You did everything right, but the tech on the other end let you down. Okay, so we've identified our culprits, but why does this actually matter to you when you're the one standing there at the checkout with a payment that just failed? Well, because this distinction defines what you can do next. And here's the crucial point. A business decline is usually something you can fix right then and there. You can double-check your PIN, pick a different account, or just try to send a smaller amount. But If it's a technical decline, there's really nothing you can do but wait for the bank or the provider to get their systems back online. But knowing who's at fault for one little failure is just one piece of a much bigger puzzle. The entire digital payment world is constantly evolving, and it's facing down some pretty big threats, like super sophisticated cyber attacks and the ongoing challenge of just earning and keeping our trust. And maybe the biggest technical hurdle of all isn't a server or a network, it's just access. Because for all this amazing complex tech, the system is still a closed door for a lot of people. In India, for example, research shows that 19% of the population still doesn't have a bank account. For them, the ultimate transaction failure is the one that can never even be started. So, the next time you see that payment failed notification, you'll know about the incredibly complex web of things that could have gone wrong. And that kind of leads us to a final question. In a world that's built on this fragile digital foundation, is a 100% perfect system even possible? Or is failure just a permanent part of the code?